Before the class, please let me introduce myself to you. My name is Chou Yue, and I am a PhD in mechanics. My research interest lies in biofluid and fluid mechanics in medical science. Here is my email address. If you have any question during the class, you can email me, but don't interrupt me during the class. And our the name of our class is college physics, and it will consist of three parts. Um, the the final score will consist of three parts. First is your attendance. It consists 20% of your final score. So in order to get a higher score, you'd better attend every class. This the attendance will based on the on whether you attend the class meeting, and we will get a final attendance uh, attendance exam form to check it. And the second part is the midterm tests. During the whole semester, we will have 2 or 3 times of midterm tests, and this will consist 30% of your final score. And the third part is the final exam. This is very important for you because it consists 50% of your final score. So before the final exam, you have to work really hard to get a better uh, final exam score. Okay, before this class, I have sent to you the textbook of our course. It is a very big book, and it has 30 chapters. Here we will see it consists of 30 chapters. We'll see it. From chapter 0 to chapter 30. But we only have 32 hours to have this course, so we don't have enough money. We don't have enough time to get all the courses. So basically, uh, we will attend the course mainly on the mechanics chapter. But we should know that the college physics consists of 6 chapters. First is mechanics. This is a fundamental part of um, current physics. So in order to do some research or do some work in the future in physics, you have to learn it. And the second part is periodic motion with and fluid. And in this chapter, you will see some periodic motion and waves. And fluid is a very interesting periodic motion. Okay, what is wrong? Hmm. Okay, we have some more students here. Um, I hope in the next class, no one would be late for the class. Because being late for the class is a kind of interruption for this course. Okay, everyone is in the meeting room. And next, there will be thermodynamics. And after learning all the three chapters, we will have some courses related to electricity, light, and modern physics. But during this semester, we will only learn about mechanics, which is a fundamental part of modern physics. Okay, let's begin. So let's begin with this letter to the student. Here is a letter from the author of this book about how to succeed in physics. For most of you, physics is really hard, uh, and some students even uh, are scared of physics. But if you want to learn this course really well, and you want to do something uh, related to physics in the future, you must do the following things. First, you need to spend the time studying. Um, you should spend time during the course. You should listen carefully, and you should also spend extra hours after this class doing some exercise, seeing videos, seeing books, and do some exams by yourself to learn this course well. And then it is a very fundamental part. Don't miss class. During the class, you can know some basic concepts uh, about how to solve the problems in physics. Um, if you want to learn this course after class, it is okay, but maybe you need to spend more hours. So listening to the class is most effective and efficient way for you to get a higher score and get knowledge. And three, make this book work for you. Um, this book is really well written, and I think every one of you should read it carefully, do the exercise. Do the exercise really hard, and then you can really know something about physics. And number four, approach physics problems systematically. Um, solving the physics problem systematically and having a systematical thinking about physics is the way is the basic idea of this class is what you should learn in this course. And number five, if you are really interested in this subject, you should really use Kepler's resources. I know during this specific time, maybe you are not uh, easy to go to school, but you, for every one of you, you have the uh, account in of library, and in the website of our school library, you can search many resources related to this course, and you should use it. Okay, I hope we can have a pleasant journey about physics in this semester. Part 1, Mechanics. What is mechanics? Mechanics is the science of motion and its cause, and it consists of two parts. The first part is kinematics, and kinematics describes motion in the world. Uh, in chapter 2 and chapter 3, you will learn the kinematics. And number 2 is dynamics. Dynamics describes causes of motion. In chapter 4 to chapter 11, we will learn about it. In order to learn mechanics, first we need to learn some basic concepts of mechanics. The first one is ideal model. In order to describe motion in the whole world, we use ideal model to represent everything. For example, we have particles and rigid body. A particle is defined as a thing that has no shape, no size, and it has only mass, and we call it particle. And the rigid body, it has shape and size, but it has no deformation. And I want to ask you whether it has mass. Okay, the answer is a rigid body has mass. So a rigid body has mass, shape, and size, but we assume that it is undeformable. We call the particle and the rigid body ideal model because it is idealized. In a real world, we cannot see something that is a particle or rigid body. But in order to describe the motion, we made some simplifications. And then you need to learn about types of motion. First, translation. Uh, or we can call it particle or we can say that every particle motion is translation. A translation is one thing that moves from one place to another place without rotation or oscillation. And then we have rotation, and we also have oscillation. Okay, let's begin with kinematics in 1, 2, and 3 dimensions. We will first learn kinematics in 1 dimension, and this is a very very simple part of this of kinematics, and then we will move on to the situations in 2 and 3 dimensions. Okay, here are some key terms you must know before we start. First is the frame of reference. And the frame of reference is related to the coordinate axis and origin point, and what is negative and positive. We will distinguish scalar, vector, and magnitude, direction, and components. Let me see. We have more. So many students are late for the class. I hope next time no one would be late for the class. Okay, here are some key terms. We will learn about position vector, displacement, path, time interval, instant, velocity, speed, and so many terms. Let's start. First one, we will learn particle motion. For particle motion, the very important term is reference frame. And it consists of quantities to describe motion and method to describe motion. We have project motion, circular motion, and curve motion to describe. The first part, scalar and vector. The scalar is defined as the ordinary algebraic quantity that has no direction or a number. In the real world, the mass, time, energy, temperature are scalars. And we have negative and positive scalars. Some scalars are always positive, whereas others, such as electric charge, can be positive or negative. Let's think what scalars are always positive. For example, time is always positive. We quantitate the time using days, seconds, or hours. We have 1 day, 2 day, or many days, but we don't have negative days, right? And I want you to think the energy. Is it always positive or it has negative terms? Energy. Yes, some students have answered me. Energy has negative and positive terms. And temperature. We also have positive and negative terms, right? So scalar is very simple. It is a number and it has no directions. Positive or negative scalars do not mean the direction. It means what? It means the magnitude of it. And then in corresponding to the scalar, we have vector. A vector quantity that has both direction and magnitude. Or we can call a vector is a number and a direction associated associated with it. For example, we have displacement, velocity, acceleration, force. They are all vectors. And for a vector, we have a unique handwriting of it. Here, for a vector A, we have an arrow points to the right side on the top of it. We have vector and we have a unit vector. A unit vector means a vector that has unit magnitude, and it is always used to indicate the directions. And we use this symbol, head of a vector, to represent a unit vector. And we can also rewrite a vector using this equation. A vector A equals the magnitude of A cross the unit vector of A. Unit vectors are always used in coordinate systems. For example, we use IJK to present the three coordinate axes unit vectors in the rectangular coordinate system. And in a coordinate system, we can um, mm, we can divide a vector into two components or three components for motion in two dimensions. We have vector A, and shown in this picture, and we have uh, the angle between A and the x-axis theta. So can we can divide the vector in two components. In the x-axis, we have ax, the vector ax, and in the y direction, we have the vector ay. We call them component vectors. And the magnitude of ax, ay are components. As we previously described, we can rewrite the vector A, and this vector A equals vector AX and vector AY. And vector AX can be rewritten as AX I, unit vector I, and vector Y can be rewritten as AY, unit vector J. And we see here is a triangle AX, AY, and vector A forms a triangle. So according to the theory of the rectangular triangle, we can calculate the magnitude of vector A. It equals squared AX uh, AX squared and AY squared. And the magnitude of AX equals A magnitude of A cosine theta and AY equals A sine theta. Okay, this is the basic concept of a vector and how to the basic concept of how to um, divide a vector into components. Very easy, right? Since we have the basic concept of dividing a vector, we can do some calculations such as vector addition. In order to do a vector addition, we need to know the basic concepts of doing it. We have two methods to do this. The first method is adding vectors by components. And the second method is adding vectors graphically. Um, for the first method, adding vectors by components, we have two vectors, vector A and vector B. In order to add the vectors, we should first what? As we previously described, in order to uh, add a vector, we should first divide the vector into components. So for vector A, we divide it into three components. This is a three-dimensional vector. So we have vector A equals AXI and AYJ and AZK. And we also have vector B, BXI and BYJ and BZK. In order to add the two vectors, we call the addition of the two vectors vector C. Vector C equals vector A and vector B. And we can add the components one by one. For example, the first component of vector C equals AX and ABX. And the second component equals AY and BY, and so on. This is the first method of adding vectors by components. And we have the second method, ending vectors graphically. Here we have two vectors, vector A and vector B. Using the triangle method, vector A and vector B equals we can do it graphically. Uh, we can do it graphically using two methods. The first method is called parallelogram principle. We can put the two vectors together, the origins of the two vectors together, and then we can draw two parallel lines of vector A and vector B. And the four lines form a parallelogram. And the and the diagonal line is the addition of the two vectors. This is the first method called parallelogram law or parallelogram vector principle. And we have the second. Okay. And we have the second method, which is called the triangle method. We can put vector A and vector B one by one. The origin of the vector B is the end of vector A, and by we put the vector origin of vector B, the end of vector A, and then by drawing the origin of vector A from the origin from the vector A to the end of vector B, we have the addition of the two vectors. And this is called the triangle method. When you solve the problem, you can use either of the two methods graphically. Now that we know how to do the vector addition graphically, use of two vectors, we can know how to do the vectors of a several number of vectors, many vectors. So here we have 1, 2, 3, 4 vectors. P1 and P1, P2, and P3, P4. So, what is the vector of P equals P1 and P2 and P3 and P4? Uh, okay, let's take a 10 minutes break, and we will leave and I hope all the students can think about it. And we will leave this question in next class after 10 minutes.